We are given three different lines and asked which two lines are parallel to each other. So we know that a linear line written in standard or in slope intercept form is written as y equals mx plus b, and our m is our slope. So the first thing we need to do is we need to make sure that all three of these equations are written in slope-intercept form so that I can take the slope out of the equation. So we need to do some rearranging. So our first line, we have 5y equals 2x plus 15. So we're trying to get y by itself. So the first thing I'm going to do is I'm going to divide every single piece by 5 and then simplify my numbers. So I get 2/5 x plus 15 divided by 5, which is 3. That means my slope of line A, I'm just going to put a little a here so I don't lose track of what I'm looking at. The slope of line A is positive 2/5. And then we're going to do that for each one of our lines. So for letter B, or line B, I have 5y equals 9 minus 2x. So same thing, first thing I am going to do, I am going to divide every single number by 5, and I get y equals 9/5 minus 2/5 x. Now the biggest trick on this is remember your slope always comes from the number in front of the x. So when I'm looking at this, I actually end up getting that my slope for line B is a negative 2/5. So take the sign with it as well. You could also rearrange this if you wanted to. If you put the slope first, take the sign with it, it would be negative 2/5 x plus 9/5. So 9/5 is my positive y-intercept and negative 2/5 is my slope. So that leaves line C, 5y minus 2x equals negative 3. We're going to go ahead. First thing I'm going to do, I'm trying to get y by itself. So the first thing I'm going to do is I'm going to add the 2x over to the other side. Those cancel out. I am left with negative 3 plus 2x, or I'm going to put the slope first since that's what I'm trying to find, and I'm used to writing it as mx plus b. Last step then, divide every single number by 5. And I end up with 2/5 x minus 3/5. So the slope of line C was also a positive 2/5. So my answer, I had line A had a slope of 2/5, line B was negative 2/5, and line C was a positive 2/5. Now as a reminder, parallel slopes are when the slopes are equal, they're the exact same slope. So letter A and letter C would be parallel slopes. Remember, if they're perpendicular, that means they're opposite reciprocals. Is the line through W and X parallel to the line through S and T? So if we want to figure out if something is parallel or not, we need to look at the slopes of the lines. So anytime we talk about parallel or perpendicular, we always need to talk about the slopes. So the first thing I'm going to do is I'm going to look at the slope of WX. I always kind of like to write down my points so that I have something to look at and I don't have to keep looking back at that problem. So W was negative 3/6, X was 9/3. I'm going to go ahead and find my slopes. Remember, you do your change in y's over your change in x's. So y minus y over x minus x. So I have 3 minus negative 6, so I'm taking my y values. And then make sure you go in the same order. So since I started with x, the point x, I did x minus w. Make sure on the bottom you also do x minus w. So I am going to do my x values for those points, which would be 9 minus negative 3. So on top, this really becomes a plus. 3 plus 6 would be 9. On the bottom, that becomes a plus. That's 9/12. Always make sure you simplify your fractions, okay, because otherwise they might not match. So I really need to simplify this, and I notice that a 3 can be taken out of both of these. So my simplified slope is 3/4. All right, now we're going to do the exact same thing for line ST. So S is 5, negative 2. t is negative 3, 4. And I'm going to do the same thing. I'm going to do the change in y's over the change in x's. So I am going to take my t minus s is how I'm going to do this. So I'm going to take my y values first and subtract them in that order. So 4 minus negative 2. And then same order, do your x values on the bottom. So negative 3 minus 5. So on the top, two negatives make a positive. On the bottom, I get a negative 8, which means my slope, if I simplify this, again, make sure you're always simplifying, I can take a 2 out of both of those. So my slope ends up being a negative 3/4. So what I ended up with is the slope of wx is a positive 3/4, and the slope of st was a negative 3/4. The question asks if they are parallel to each other, and my answer would be no, they are not parallel, because if they're parallel, they must have the same slopes. So I am going to say not parallel. Because they do not have equal slopes. Now I'm going to ask one more question because I know that this is very likely to pop up sometime. What if I asked, are they perpendicular to each other? So I know the question doesn't ask this, but it's a very likely question for it to pop up on the test. So are they perpendicular to each other? And remember, if they are perpendicular, that means that they are opposite reciprocals. And opposite reciprocals means you need to flip the sign and you need to take the reciprocal. So if I have one of my slopes as positive 3/4 and I have my other slope as negative 3/4, are they perpendicular to each other? First thing you look at, are they opposites of each other? Do they both have different signs? So on my first slope it's a positive, my second slope is a negative, so the opposite part of this is true. Yes. Are they reciprocals of each other? Can you flip them upside down? So they're both 3/4. Reciprocals means that one would be 3/4 and the other would be 4/3. So they are not reciprocals of each other, which means no, these are not perpendicular. So these are neither parallel nor perpendicular. The Chicago Fire is going to Columbus to play the Columbus Crew in a soccer game. A coordinate grid is superimposed onto a highway map between the two cities. The Chicago Stadium is at point 722 and the Columbus Stadium is at point 246. The map shows a highway rest stop halfway between the two cities. What are the coordinates of the rest area or rest stop? So the halfway point is implying to us that halfway between the two is where the rest stop is. We want to find the coordinates of that rest stop. This halfway is telling me that I need to find the midpoint. So we have a few formulas that we used in Unit 2. One of them was the midpoint formula. And when you find your midpoints, all you need to do are take your two x values from your first and second point, add them up, and divide by 2. That will give you the coordinate of your x value. And then to find the coordinate of the midpoint of the y value, you take your y values and add them up and divide by 2, and that will give you your midpoint. So that's exactly what I'm going to do. I'm going to take my 2 points. I'm going to take my x values first. So my x values are 7 and 24, and I'm going to add those 2 up. So to find my midpoint, I am going to take the 7 and the 24, add them up, and divide by 2. So when I add those 2 up, I get 31. Divide that by 2. 31 divided by 2 is 15.5. So the x value of my midpoint is 15.5. And then we do the exact same thing to find the y value. We have 22 and 6 as my y values. So we're just going to go ahead and you're going to take 22 plus 6, add them up, and then divide by 2. So 22 plus 6 is 28. 28 divided by 2 is 14. That means my midpoint is at 15.5, 14. Write the equation of the line that is perpendicular to 7x minus 3y equals 8 and also contains the point W. All right, so I need to first find a line that's perpendicular. So perpendicular, all I know is I need slopes that are opposite reciprocals of each other in order for them to be perpendicular. So the first thing I'm going to do is I am going to find the slope of this original line so that I can find a line that's perpendicular to it. So I'm going to take my original line, 7x minus 3y equals 8, and we're going to go ahead and find the slope. So in order to find the slope, we need to get y by itself. So the first thing I'm going to do is subtract 7x from both sides. And then divide every single piece by -3. And I get y equals, two negatives are going to make a positive. So this is now positive 7/3 x minus 8/3. So I have that the original slope of that first line is 7/3. So we need to take that 7/3, and that's the slope of my original line. The new line that I want to create is going to be perpendicular. So remember, if it's a perpendicular line, you want opposite reciprocals. So opposite means I need to flip the sign. So it was originally positive, it needs to be negative. And then reciprocal, I need to flip my fraction upside down. So this is an example of two slopes that are perpendicular to each other. So the last thing I'm going to do is I am going to rewrite my equation using this point and plugging in my equation and writing my new equation. So I have two ways I can do this problem. One of them was to use point slope form that was given to us earlier in the chapter. And basically all you need to do is you need to take your slope that we found above and take your y and your x value from your point that's giving to us that we need to include, and that will just give us our answer. So if I do it this way, and I'll show you both ways and you can do whichever way you're more comfortable with. If I plug in the y value, when I plug in the y value, actually I'm going to go ahead and put in my other blanks. All right, so when I plug in the y value is 11, so y minus 11 equals my perpendicular slope, which was -3/7, and then x minus a -6. So when I plug in a -6 here, that's actually going to turn into a +6. So simplifying, this needs to go to both pieces. So I get -3/7 x. When you multiply fractions, you're going to multiply straight across. So top times top, bottom times bottom gives me -18/7. And then your last step is you need to add 11 right here to both sides, and that will give me my ending answer. And you can do this a couple different ways. You can just put it on your calculator if you're very careful with your parentheses. -18/7 plus 11. On your calculator, we will end up getting a +59/7. And that would be my answer. If you don't have a calculator and you're doing this by hand, you're taking -18/7 and you are adding 11, which is really 11/1. You would want common denominators, so you need 7s on both bottom and top. So I'm going to multiply this back fraction by 7 on top and bottom. So 77/7 is really the exact same thing as 11. Since they're different signs, I would add them up, and that's where the 59/7 comes from. Your other option is, if you don't want to do the point slope form, what you can do is you can just do y equals mx plus b, and we don't have the y-intercept, we have to find it. So what you could do is you could just take your x and y value and plug them in. So 11 equals my perpendicular slope, which is -3/7 x. I know what x is, so I'm actually going to erase that. My x value given the point in the problem, my x value is -6 plus b, and I'm going to solve for b. So if I go through and I solve this, notice I get 18/7 plus b. To get that, to get b, I would have to subtract 18/7. And if you notice, I'm now at the point where I'm doing 11 minus 18/7. Well, that's the exact same thing I did over here. It's the same exact numbers. It's just written a little bit differently. So again, you're still going to end up getting b is 59/7. So this is one way to find b, and then what you do is you just go back in one more time. You plug in the slope and you plug in b. So you would get -3/7 as your slope, and your y-intercept is 59/7. So there's two ways of doing this problem. They both give you the same answer. If you do point slope form, your ending answer will already be completely finished for you. If you just plug it into y equals mx plus b, you're going to solve for your y-intercept, and then you still need to go back, plug in your slope, and plug in your y-intercept into the equation. Either way is correct. Either way works. Write the equation of the line that is parallel to y equals 5x plus 4 and contains a 1, 7. So this is pretty much the same problem we just did as the last one, except it's parallel. And the good news is this equation is already written for us. So I know that the original line has a slope of 5. So that means that if I want to do a parallel line, parallel means same slopes. So when I write my new equation, I want to use a slope of 5 as well. And then I need to include the point 1, 7 as my x and my y. All right, so there's again two ways you can do this. You can do it whichever way you are more comfortable with. I'm going to do them both. If you want to stop watching after the first one, that's fine. But if you're using the point slope form, our equation that we would use looks like this, and it will find our y-intercept for us this way. So all you have to do is plug everything in. So your y value was 7. Slope is going to be 5 because it's parallel. Remember, if it's perpendicular, then right here I would want to put -1/5. You'd want to do the opposite reciprocal if this was perpendicular. But it's not, so parallel, we'll leave a 5 in there as our slope, and for x, we have a 1. And then we're just going to simplify. So y minus 7, distribute that to both pieces, you get 5x minus 5. Last step, add 7. And my ending answer then is 5x plus 2. So that is our new equation. It has the 0.17 that it crosses through and a slope of 5. Your other option is just to take y equals mx plus b and solve for b. So you have m, and you have your x, and you have your y. So just plug in all three numbers, 7, 5 for your slope, x is 1, and solve for b. So if I solve this, I get 7 equals 5 plus b. Subtract 5 from both sides. I get that 2 is equal to b, so b is 2. So then what you're going to do is you're just going to come through one more time, and you're going to plug in m, and you're going to plug in b, which is your y-intercept. So you get y equals 5x, and then your y-intercept is 2, so you get 5x plus 2. Notice this is the same answer either way you do the problem. Choose the best name for each quadrilateral. So I have written the 7 different quadrilaterals across the top of this slide of my answers that I can choose from. And I've kind of lumped them together in a specific way to kind of help with these problems. So what I know about the first two, between a square and a rhombus, is that all 4 sides are equal to each other. The next set, rectangle, parallelogram, and kite, these all have 2 pairs equal to each other of sides. So on these two, it's 2 opposite sides equal, and a kite has 2 consecutive sides equal to each other. And I should say pairs. So not just 2 sides, but 2 opposite pairs. So the left and the right, the top and the bottom are equal to each other. On a kite, 2 consecutive means next to each other. And then the last one, there's no equal sides. There's one set of parallel lines. An isosceles trapezoid will have one set of equal sides. A trapezoid will not. All right, so as you go through these classification problems, you're going to do them in 2 different steps. The first step you're going to do is you're always going to look at the lengths of your sides first. So when I look at the lengths of the sides, I notice that I have 1 pair of sides that is the square root of 10. I also have a second set of sides that has the lengths of square root of 13. So right now I know that I have two pairs of equal sides. And I know that if I have two pairs of equal sides, that means that it could be a rectangle, it could be a parallelogram, or it could be a kite. And I'm going to abbreviate here. So what I'm going to do is I'm going to draw a quick picture of this so that I can tell if it is opposite sides are equal to each other or is it consecutive sides, because that will narrow down some of my choices. So AB is the square root of 10, BC is the square root of 13, CD is the square root of 10, and AD or DA is the square root of 13. So what you notice is opposite sides are equal to each other, which means kite is eliminated because kite is consecutive sides. So the first thing I want to write down is how every time you narrow down your choices from the original 7, you want to explain what it is. So in this one, the first thing that narrows down my answer is that I have two pairs of opposite sides congruent to each other or equal to each other. So that narrows down half my answer. But I still have to decide between a rectangle and a parallelogram. And the only thing that's different about a rectangle and a parallelogram is that a rectangle has right angles and a parallelogram does not. But they still have opposite sides equal to each other. So the last thing I need to do is look at the slopes, and that is step 2. So step 2, you look at your slopes and you decide if you have perpendicular lines or not. Perpendicular lines would mean right angles, and then I would have a rectangle. If I don't have perpendicular lines, I can cross off rectangle, and my answer would be parallelogram. So I look at my slopes. I have a slope of a positive 2/3, and I have a slope of negative 3/2 in the corners, because you want to look at the two sides that are right next to each other. Okay, so you have a 2/3 and a negative 3/2. So you have to look at the sides next to each other because you're trying to figure out if right here in the corner, do they meet at a right angle? So if they're perpendicular, they are opposite reciprocals. And I'll do the next two examples a little bit quicker. But opposite means opposite signs. One is positive, one is negative. So the opposite part is true. Reciprocals are the fractions flipped upside down. That part is true. Since both of them are true, this is opposite reciprocals, or these are opposite reciprocals, so we do have perpendicular lines. So if you have perpendicular lines, that means you have right angles. And if you have right angles, that means that this answer is rectangle for letter A. So I'm going to do this again for both problems the exact same way. So first step for letter B, narrow down your choices from the side lengths. So if I look at this 1, 2, 3, 4, so I have 4 equal sides. So if I go up to my list and I look at my 4 equal sides, I can narrow my answers down to 2 choices, a square and a rhombus. That's step 1. Step 2, and you guys, this is important because you do need your explanations, so make sure you're writing down your explanations as you go. Slopes. Do they have right angles or do they not have right angles? So when I look at my corners, and notice I didn't draw a picture on this one because it doesn't really matter. All 4 sides are equal. I don't have to really label it and decide on opposite sides. So my slopes are 2/5 and negative 2/5. Are they opposite reciprocals? So when I look at the signs, one is positive, one is negative. So the opposite part is true. Are they reciprocals of each other? The answer is no. So you do not have perpendicular lines, which means that you have no right angles. So no right angles means it cannot be a square, which means letter B, my answer is rhombus. All right, one more time, same thing. Start off at the beginning. Look at the lengths first. I have 1, 2, 3, 4 equal sides. 4 equal sides narrows down my choices. I can narrow it down to a square or a rhombus. Step 2, look at your slopes. My slopes are negative 4/3 and a positive 3/4. Are they opposite reciprocals? Opposite signs. One's negative, one's positive. So yes, they're opposite. Are they reciprocals? 4/3, 3/4, flip upside down. Yes, they're reciprocals. So I'm going to put a little note here. I have opposite reciprocals. I have perpendicular lines. If you have perpendicular lines, that means you have right angles. If you have right angles, you cross off rhombus, and that means your answer is a square. So A was rectangle, B was rhombus, C was square. For numbers 16 and 17, so we're using the same triangle as the last problem, and it says you have triangles A, B, and C, and find the perimeter. So perimeter means to add up all the sides, and since we have a triangle, there are 3 sides together. So if we need to add together our 3 sides, all we need to do is take the 6 plus 10 plus 4, and you get that the perimeter of this triangle is 20. It's a very easy problem. In our unit 2, just as a reminder, I'm making these numbers up right now, but let's say I had the square root, 2 times the square root of 10 plus 2 times the square root of 10 plus the square root of 21. Just as a quick reminder, you cannot add together radicals unless it's the same radical underneath. So again, I am making up this. This is just a total side problem with made up sides. So 2 root 10 plus 2 root 10 if you want to add them together. If you have 2 of one thing and you add together 2 of another, you now have 4 of those same exact things. So 2 root 10 plus another 2 root 10 means you now have 4 square roots of 10. So you're adding the numbers out in front. You don't have to add the numbers underneath the radical. Plus the square root of 21. They don't have the same radicals underneath, so you cannot add them together, which means this would be your ending answer for the perimeter if it were a problem that had square roots.